way, and there are a lot of other ideas being explored. So these are the few which are really popular and picking up.
सिलिसीन यूज़ नहीं होती है, सिलिसीन ग्राफीन का काउंटर पार्ट। मैंने पढ़ा था कि कार्बन नैनो ट्यूब को यूज़ नहीं कर सकते।
So carbon nanotubes are found in like silicon.
इसमें लिखा था कि सिलिसी इग्नोरेट करिए, सेम एग्जैक्टली वही प्लेन स्ट्रक्चर होता है कार्बन का ग्राफीन में, तो सिलिसीन ज़्यादा मतलब अडेप्टेबल है इसके।
Wrong orientation of the carbon molecules and they won't be fit for this thing. So what currently biggest hurdle that carbon nanotube people are facing is how to select the best carbon nanotubes. So that selection is very difficult. If you select a wrong one, instead of having 5x improvement, you'll have 2x degrade. So those are found naturally in the environment. All you need to do is try to find the best ones for your use, which can provide the benefit. So there's no extra cost. The cost is in selecting all the right ones. How you design the testing, that's the cost. But the manufacturing cost is not. Yeah.
Yeah, I think how use of carbon nanotubes prevents the leakage.
Yeah, so that's again an issue. So in that, the thing is your performance is increasing so much, right, that you can have. So in that there is still problem of leakage current, but your performance is increasing so much that people are saying that instead of the leakage current, our performance is so good that it's fine. Right? So actually I spoke about the difference between ion and IOF. Right? In carbon nanotube, ion will increase so much that the difference will become good enough. Right? Even though IOF has increased, ion also has increased. So it's fine, leakage can happen, but we have enough difference there. So you can reduce your voltage probably and reduce the leakage because of that. So you can try different things. Performance impact is the main thing that you know. So this is a summary of the future. So right now the world is on 20 nanometers using planar CMOS. In fact, Intel is on 22 nanometers using but after this there is not going to be any planar CMOS. So all the companies including TSMC, Intel, everybody is going to design only FinFETs up to at least 7 nanometers. So that's another 2 generations after this. So after 20 comes 14 and then 7. That's how it goes. So you still have a roadmap for another at least 5 to 6 years. You don't need anything else. And after that, who knows? Again, I'm thinking that there is research going on of using materials outside silicon, like carbon nanotubes, and that will take over at some point of time when the FinFETs die out. So these silicon is replaced by carbon nanotubes, or it can also be replaced by germanium in a certain way that you can have better control over your leakage and more performance. So that's one thing. So again, we are at 20 nanometers, we did see 1000, below 1000. The demand for better performance, lower power and smaller area will always push everyone in the industry to make better products and to innovate. So there's no end to innovation in electronics. There's nanometers now, there'll be something else after that. After 7, there'll be 4, there'll be 3, and there'll be all sorts of things. There's a lot of innovation required to make all of them happen the best possible. And this demand seems to be increasing at the rate of knots. Every year, the smartphone industry wants more and more bandwidth and more speed of the internet. And there's no end to performance requirement.
Consumerism promote कर रहा है.
Everybody wants the cheapest one. So it's all on the way up. Slowly, everything is on the way up. So that's all the technical stuff. So any other last question related to technical? So this is more like a suggestion slide and the different opportunities in India and why the electronic students in this can look forward to a career in electronics without worrying about things like money. So I have limited knowledge in comparison to professor, but the semiconductor industry has become pretty large and varied, and So the main driving factor is cost saving. You can pay, you can open a site in India and pay 2x lower than the US salary, and you will still be 2x higher than the average Indian salary. So that's what's making them come to India more and more. They want cost saving, and they know that there's talent. You can have cost savings in Africa also. You might not have as much talent in Africa as in India. So that makes them want to come to India, and most of the major companies have at least one or more offices in India. So some of the companies are Intel, Nvidia, Cypress, Xilinx, LSI, FTScale, Qualcomm, Broadcom, Honeywell, just to name a few. And everybody has everything from R&D to design to verification done in India. It's not like they only give only verification to India. All the innovation, it's not like all the innovation happens only in their headquarters. They've spread out the innovation and R&D across all the countries, and especially in India. They want R&D to be driven by India as well. So there's a lot of innovation opportunity in India, and India is no longer a place to only outsource work, at least in electronics. Right? And Cosmic and Sankalp Semiconductors are some of the great startups from Indians, and they're great places to work for people interested in analog design. They're doing some great work. They're getting deals with top-notch customers, which have traditionally been going to American semiconductors. So some tips and suggestions is that PS2 is very, very, very important, and so don't go for money. Choose very carefully. I went for Cosmic, even though the stipend that they were giving was at least 2 times lower than all the other big companies like Intel and all that. But the work there was incredible, and that has launched my career at an early stage. Because of PS2, I'm able to work on these areas and try to read up about the latest happenings in electronics during college days. I didn't do that, so it's easier said than done. But if you can just go through some of the commonly visited sites, like so there's typically Electronic Times, and there are 2 or 3 other useful sites. They just talk at a layman level, at a starter bachelor level, what the electronics industry is going through and what's happening, and it gives good summary. I'll keep you up to date with what's happening, and pay more attention in class when you know that it's actually been the lesson in class has actually been adopted in some technology in the world right now, which is driving everything electronics. So there's all sorts of work happening in India. Try to identify yourself with some of that work, like layout design, circuit design, digital or analog level, device level research, which I am doing to some extent, and architecture, CAD tools like Virtuoso, Cadence, all of them, Synopsys, they all have offices in India, and these tools are very important because all the fabulous companies in the world don't have any idea of what the transistor characteristics are, because they are made by the fab, right? So all these tools are very important to integrate a fabulous company with a fab company, and to make things more streamlined and make things easier for the designer as well as the fab. So CAD tools are also very important, and people who are a little bit inclined towards software and coding side can also look at this as a combination of electronics and computer science. And there's also verification and testing. There's technical sales and marketing, which is also very interesting. And one of my uncles recently has shifted from a completely technical circuit design role to a technical sales role, and he's witnessing great stuff there. He's like, when I interact with my customers now, I have to be completely technically sound as well, but I need to be able to sell my product as well. So I'm combining my previous knowledge over the last 20 years in circuit design with now new skills attained in marketing and sales. So that technical sales and marketing is not about selling products, it's about knowing your thing well enough to sell it. That's something interesting I've noticed in the past few years. And but even though it's good to identify yourself with some work, don't be too specific. You don't want to restrict yourself in the future. So don't just think that you like one circuit design technique and you want to be a circuit designer. You need to explore everything at least once and try to see which one you really are inclined towards. So, and my personal experience is should try to work in the. I've seen too many people who go for masters right after graduating from bachelors, and I feel that since I worked in the industry for 2 years, I'm much more prepared to go for higher studies like PhD and masters in the future than those people. That's what my feeling is personally. So it's not everybody in my family tries to say that once you leave college you start working. You will become this workaholic person who wants to earn money and who does not want to learn anything anymore, and you won't go for masters. But I don't agree with that. I feel that in my work I've been lucky to work on great stuff, and that's made me even more motivated for higher studies and better prepared. So and pay attention in class. I'm realizing how important that turned out. I got decent grades. So yeah, it's important to pay attention in class. All this stuff is going to be applied as soon as you go for your first job. So yeah, that's about it. I want to thank Sureka Bharat ma'am for giving me the chance to address the students, and it feels great. I just passed out a year back, and coming back and talking in front of students is awesome. And also I couldn't make it to the convocation last year, so I want to thank all my EEE and ANI professors for their support during a very tough season. It's good to have such supportive professors.